Hi, hello. This is Sudha Malli, Assistant Professor, Department of Civil Engineering. Today, we are going to learn about Tachyometry surveying from Rohini College of Engineering and Technology, Kanyakumari. So, tachyometry. It is the branch of angular surveying the horizontal distances from station to the stop, and the vertical distance of a point are determined from instrumental observations. So, horizontal distance. Horizontal distance, it means the instrument set at A station, then bisect the B point, then focus their point. The formula is D is equal to Ks plus C. Then vertical distance, the point in fixer A station, then side to the B object, then this is vertical, then that means height of the object. So V is equal to ms sine 2 theta divided by 2 plus C into sine theta. So additive constant and multiplying constants are there. Multiplying constant f by I, additive constant f plus c. S is the staff intercept. Theta means angle between horizontal line of sight and the middle cross hair. Then objects of tachyometer. What is the purpose? Preparation of contour maps or plans used in hydrographic survey, location survey for roads, railways, reservoir and etc. for checking of more precise measurements. Then in which situation tachyometry can be used? When obstacles like river, broken ground, stretches of water, tachyometry gives speed and accuracy to work. In rough country, where measurement of horizontal and vertical distances are difficult, inaccurate and slow. In locating contours and filling details in a topographic survey, this method is fast and best. Then difference between the tachyometer and theodolite. So in theodolite, it is used for measurement of horizontal and vertical angle. In tachyometer, it is used for measurement of horizontal and vertical distances. In theodolite survey, distance are measured by chain or tape. In tachyometry survey, direct measurement of distances are possible. Then in theodolite, suitable for plain and hilly area with less obstacles. In tachyometer, suitable in case obstacles like river, broken ground. More situations are recorded in theodolite survey. Less stations are recorded in tachyometric survey. These are the differences in between theodolite and tachyometer. Then constants of tachyometer, multiplying constant and additive constant. Multiplying constants, that is f by I or m. Additive constant f plus c or c, where f is focal length of image glass, c is the length of image. Then what are the instruments used in tachyometer surveying? So tachyometer and the leveling or stadio rod. Tachyometer, it is a transit theodolite provided with a stadio diaphragm. A diaphragm is provided with two horizontal stadia hairs in addition to regular crosshair. Additional hair should be equidistant from central one. Types of diaphragm commonly used as follows. This is the types of diaphragm. Next one, leveling staff or stadia rod. Leveling staff or stadia reduced with the tachyometer may be used usual type of leveling staff. It may be folding or telescopic with in 5 centimeter to 15 centimeter, height 3 meter to 5 meter. It may measure meter, decimeter and centimeter. The types of telescopic in tachyometry. External focusing, internal focusing, external focusing fitted with analytic lens. So then what is it, analytic lens? It is an additional lens generally provided in the external focusing tachyometer between object glass and eyepiece. Advantages of analytic lenses: for calculation of horizontal and vertical distances, constant. That means F plus C is equal to 0. If tachyometer is provided with the analytic lens, if the calculation becomes simple, then essential characteristics of tachyometer. So characteristics, the value of constant F by I is 100. Then additive constant F plus C is equal to 0. The telescope should be provided with the analytic lens. The telescope should be powerful. Magnification should be 20 to 30 times the diameter. The vision through the telescope should be clear and bright image at longer distance. Then tachyometric methods. So stadia system, there are two systems, stadia system, another one is tangential system. The stadia system once again classified two types, fixed hair method, another one is movable hair method. So first of all, stadia system, it means tachyometric angle is constant. Staff intercept varies with the distance between staff and instruments, which forms base. Diaphragm of tachyometer is provided with two stadia hairs, that means upper and lower. Telescope is directed towards the staff held at a point whose distance from instruments is to be found. Difference in these readings gives staff intercept. Horizontal distance is obtained by multiplying staff intercept by multiplying constants. There are two methods. First one is fixed hair, another one is movable hair. Fixed hair method. In this method, the distance between two stadia hair is fixed. The readings corresponding to this cross hair is taken and difference between top and bottom hair is found out, known as staff intercept. Then fixed hair method. There are three different cases used. In case 1, line of sight is horizontal and the staff held is vertical. Then in case 2, line of sight is inclined and the staff held is vertical. Then the last one is line of sight is inclined and the staff held is normal to the line of sight. Line of sight is horizontal and the staff held is vertical. So horizontal distance formula is F by I, that means M, S plus C, that is additive constant. Then in second case, line of sight is inclined and the staff held is in vertical. Then vertical distance V is equal to F by I is that is multiplying constant into S, that means staff intercept sine 2 theta divided by 2 plus F plus C, that means additive constant sine theta. Then the horizontal distance D is equal to F by I, it's a multiplying constant S cos square theta plus F plus C, this is the additive constant, then cos theta, where theta is the angle between horizontal line of sight and central readings. Then in third case, line of sight is in inclined and the staff held is in normal to the line of sight. In third condition, line of sight is inclined and the staff held is in normal to the line of sight. In this method, the angles are considered in elevation, means the values in positive. Considering the angle of depression means it's negative, consider as in negative. So positive means the horizontal distance D is equal to L cos theta plus H sin theta. Then vertical distance V is equal to L sin theta. In negative condition, horizontal distance D is equal to L cos theta minus H sin theta. V is equal to, that means vertical distance V is equal to L sin theta. Then another one method, movable hair method. In this method, the staff intercept is kept constant but the distance between the stadia hairs is variable. The diaphragm consists of a central wire fixed with the axis of the telescope. The upper and lower stadia wires can be moved by micrometer screws in a vertical plane. The distance by which the stadia wires are moved in measured according to the number of turns of the micrometer screws. Then the last one method, tangential method. The diaphragm of the tachyometer is not provided with the stadia hair. The reading are taken by the single horizontal hair. To measure the staff intercept, two pointing are recorded. The angle of elevation or depression are measured, and their tangents are used for finding the horizontal distances and elevations. This method is not used for generally. So, okay, thank you.